Good morning. You'll notice that I'm not going to be in class today, but I decided to make a short little video to demonstrate how you would do the next type of problem. Okay, so the problem here reads, calculate the limiting reactant and the theoretical yield in grams if 48 grams of aluminum reacts with 63.4 grams of oxygen according to the following reaction. Okay, so the first thing that we need to do, as I've said 100 times before, is we need to identify what we have. So the first thing that we have is 48 grams of aluminum, right? And so that's here in our balanced equation. The second thing that we have is 63.4 grams of oxygen, which is here, okay? And ultimately, we're trying to find the theoretical yield of aluminum oxide, right? The theoretical yield is always going to be the product in a chemical reaction. So as always, we always start with what we're given. So we write our givens and put them over 1. So 48 grams of Al and 63.4 grams of oxygen, both over 1. Okay, and these are both going to require 3 steps to get you to your answer. The first one is we need to follow the mole roadmap, or the Stoich roadmap, if you will. So mass to moles to moles to mass, right? So the first conversion that we need to do is to go from mass to moles. And we've talked about this before. We need the molar masses. So the molar masses in this case would be for aluminum and for oxygen. So looking at the periodic table, you know that the molar mass of aluminum is 27 grams and that the mass of 2 oxygens are 32 grams. Each of these 1 mole respectively, because as we've defined in the past, the molar mass is the mass of 1 mole of that specific substance. The second thing that we now need to do is to convert from moles of one substance to moles of a second substance. So when we read this question again, it says that we want to find the theoretical yield. And as I said a few moments ago, the theoretical yield is the product, right? So we want to find Al2O3, aluminum oxide. So the second step is a mole to mole conversion. In order to do that, we need 2 mole ratios. The mole ratios come from the coefficients in a balanced equation. So in this case, I'm trying to get to aluminum oxide. So that goes in my numerator. And the first conversion uses the coefficient for aluminum, which is 4. So I have a 2/4 ratio. The second one still has moles of Al2O3 in my numerator because I'm still trying to get to it. But in this case, the coefficient for oxygen is not 4, it's 3. So 3 moles of O2. Okay. And then last but not least, we're trying to get from moles to mass, right? The question asks for the theoretical yield in grams. So what we need to do is we need to find the molar mass of aluminum oxide. 2 aluminums and 3 oxygens. So 27 times 2 is 54 plus 16 times 3, which is the mass of oxygen, which is 48. So we have a mass of 102 grams of Al2O3. Molar mass again, this is the molar mass, so it's 1 mole. Okay, and so in order to actually figure out the answer, right, the theoretical yield, the lowest of the 2 results, we have to do some multiplication and division. We have to do some math. So we're going to start with our 48, divide by 27, it's in our denominator. Multiply by 2, divide by 4, and multiply again by 102. and we get 90.7 grams of Al2O3. Do the same thing again below, so 63.4, excuse me, divided by 32 times 2 divided by 3 times 102. Get to 134.7 grams of Al2O3. So we've done the hard part. Now we have to answer two questions. The first question is, which is the limiting reactant? Well, you can determine that based on which of the two answers you got was smaller. So by looking at the two answers that we got, we can definitely see that 90.7 grams is smaller. Okay, so that must mean aluminum is my limiting reactant. It is going to limit me from producing more product. My theoretical yield is this 90.7. Theoretical yield, 90.7 grams. Because at that point, after I've produced 90.7 grams of aluminum oxide, my aluminum will have run out. Okay, so hopefully this makes sense to you. All I've done here is I've set up two separate mass-to-mass problems and then converted them to the product, to the product that we wanted. And in this case, there's only one product, which is aluminum oxide, Al2O3. So I had to convert to there.